Here's a little bit of a programming puzzle to think about to start our video. Why would you ever want to limit the maximum size of a password in your web app? Does that make any sense at all? And your gut reaction might be, well, of course, it makes no sense, because what's happening when we enter a password, hopefully you're not storing that password in the database. Instead, you're creating a hash of that password, and those hashes have a fixed length. So whether you type in a password of 10 characters or 1,000 characters, the resulting hash is going to be the same size. So no matter how long it is, your database column, if you size it according to that hash size, it's going to be fine. But notice something in Laravel. I'm going to switch over here to the code, and I'm in the password rule, and sure enough, there's a max method. Why did Laravel add this? And this was added, I think, in version 10, kind of later in the release life cycle. Why did this get added? Because it can't be because we're storing plain text passwords. You would have to go way out of your way to even try to store plain text passwords in your database in a Laravel app. Like the default, it's going to be hashed. It's going to hash it with bcrypt. It's going to have a certain number of rounds. Like, security is sort of baked into the defaults of how we build the app. So why does this exist? Well, let me show an example first and talk a little bit about what's happening under the hood and why this exists. So the hashing algorithm, as I mentioned, is bcrypt. And what bcrypt does is it takes the input of your plain text string, it chops up into bytes, and it creates a hash. But let's start this with a password of 72 bytes here. And just to be precise, string random is generating 72 characters, but they're ASCII characters, so therefore it's also 72 bytes. It's a nuance that's a little subtle, but it'll become important as I describe this. So we could say our password is 72 characters, or we could say it's 72 bytes for the purposes of this code sample. But this is the plain text password. Then I take that plain text password and I create a hash out of it. So this is using bcrypt under the hood if I'm using the Laravel application defaults, and it's returning a hash. And now that hash is much shorter than my original 72 character password, and it's a hash value. I can't read the source password. Then this is like what would happen during login. It takes the plain text password, maybe you're typing into a login form, and it's comparing it against the hash. Do these things represent the same thing? And it should return true, because in this case, I'm taking the password, I'm creating the hash, I'm directly checking it. That's great. Now, let me show a slightly different example, because the way hashes work is if you change even 1 byte in the text input, it generates a completely different hash. So it's not like 1 byte difference in the password is 1 byte different in the hash. It's like a completely different hash. So if I were to say, take this plain text password and add a bunch of text onto the end of it, should it match? Let's look at a demo. So if I take my original plain text password and I concatenate on, this should not match now, and I store that in a variable longer, and I'm not creating a new hash, I'm just saying, I'm essentially typing this longer password into the login form, and I'm checking it against the original hash with the shorter password. Notice what happens. It still matches. So this is completely unintuitive at first glance. It kind of took me by surprise when I noticed what was happening here. And so internally, bcrypt truncates that incoming plain text to 72 bytes. And this is where the distinction gets a little important. A character isn't always a single byte. There are multi-byte characters, right? Emoji, things like that. So we need to say precisely 72 bytes. And I'm not going to go into a tangent as to why bcrypt does it, but just know that it does. And because of that internal behavior, you get this unexpected outcome where 2 different passwords will actually match the same hash, so long as the first 72 bytes are the same. So this demo shows why Laravel has a maximum rule. And this isn't just like some esoteric thing. There are real world applications, not even Laravel applications, but just real world PHP applications using bcrypt that made some mistakes where this actually impacted things, where like a blank empty password could match any user account. So maybe I'll put a link in the description if you want to read up on a CVE where this actually happened. But this is something important to know about. I just want to point out one more detail here, because this max is characters. So if your app allows multi-byte characters in the password, if you're not limiting it to just ASCII characters, this gets a little nuanced. You might actually have to set it much smaller than 72 characters to stay within that 72-byte limitation. So that's something to be aware of. It explains why Laravel has a max password length option, and it's something you might want to look at your app to see if you're vulnerable to this and tighten up that security so that inadvertently passwords that don't match would actually be considered to be matching in your application.